A lost neutral condition combined with an improperly grounded electrical system creates a significant fire hazard. When the neutral conductor at the service point is compromised due to a faulty connection, substandard materials, or an undersized connector, the 120-volt temporary wiring can become energized at 240 volts. This occurs because the neutral conductor serves as the reference point for the electrical system. Its absence disrupts the voltage balance, potentially doubling the voltage on the hot conductors. If the temporary wiring lacks proper grounding, there is no designated path for the excess voltage to safely dissipate. This can lead to a dangerous voltage buildup within the wiring, substantially increasing the risk of a fire. Furthermore, a loose grounding clamp on the grounding rod exacerbates the situation by hindering the electrical system's ability to effectively ground. This lack of proper grounding makes a fire ignition even more probable. Let's examine a detailed sequence of events that can unfold in such a scenario. 1. The neutral conductor at the service point fails due to a faulty connection. 2. The voltage on the hot conductors doubles, reaching 240 volts. 3. Because the temporary wiring is ungrounded, there is no path for the excess voltage to escape. And 4. The voltage accumulates within the wiring, posing a heightened fire risk. To prevent such hazardous situations, several critical steps must be taken. Firstly, properly ground the electrical system in accordance with the electrical codes and standards. This establishes a safe path for fault currents to flow, minimizing the risk of electrical shock and fire. Secondly, use properly sized and rated connectors that are compatible with the conductors being joined. This ensures a secure and reliable electrical connection, preventing overheating and potential failures. Thirdly, implement a regular inspection schedule for the electrical system. This allows for early detection of any issues, such as loose connections, damaged wiring, or corroded components. Addressing these problems promptly can prevent them from escalating into more significant hazards. By adhering to these preventative measures, the risk of electrical fires can be significantly reduced. The absence of a neutral connection can create a series of issues that elevate the risk of fire. The grounding system plays a critical role, and any compromise to its integrity, such as a loose clamp, further compounds the danger. In a properly functioning electrical system, the neutral conductor carries the return current from electrical loads back to the source. It is intended to be at or near 0 volts relative to ground. When the neutral connection is lost, the voltage balance in the system is disrupted. In a typical 120/240 volt single-phase system, 2 hot conductors, each carrying 120 volts relative to neutral, supply power. With the lost neutral, the loads connected to each hot leg effectively become a series circuit. The voltage across each load then depends on the relative impedance, or resistance to alternating current, of the loads. Loads with lower impedance will receive a smaller share of the 240 volts, while loads with higher impedance will receive a larger share. This can result in some devices receiving significantly over voltage, potentially damaging them and creating a fire hazard. Grounding provides a low impedance path for fault currents to flow back to the source, causing the circuit breaker or fuse to trip and de-energize the circuit. Without proper grounding, fault currents may not be sufficient to trip the overcurrent protection device, allowing the fault to persist and create a fire hazard. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel. The grounding electrode is connected to the neutral conductor at the service entrance, creating a single point where the neutral and ground are bonded. This bond is crucial for providing a low impedance path for fault currents. In addition to the grounding electrode, equipment grounding conductors are run with the circuit conductors to all outlets and equipment. These conductors provide a path for fault currents to flow back to the panel from any point in the system. If a fault occurs, the equipment grounding conductor provides a low impedance path for the fault current to flow back to the source, tripping the circuit breaker or fuse. The loss of neutral can lead to erratic voltages throughout the electrical system. Some devices may experience overvoltage, while others may experience undervoltage. This can damage sensitive electronic equipment and create a fire hazard. Overvoltage can cause insulation breakdown, leading to short circuits and arcing. Arcing can ignite nearby combustible materials, causing a fire. In addition to the voltage imbalance, the loss of neutral can also create a shock hazard. If a person comes into contact with a live conductor and ground, they may receive a severe or fatal electrical shock. Proper grounding helps to minimize the risk of electrical shock by providing a low impedance path for fault currents. Regularly inspect the grounding system to ensure that all connections are tight and free from corrosion. Check the grounding electrode to ensure that it is properly driven into the ground and that it is not damaged. Test the grounding system with a ground resistance tester to verify that it is providing a low impedance path for fault currents. The use of substandard or improperly sized connectors can also contribute to the risk of fire. Connectors that are not rated for the amperage of the circuit can overheat, leading to insulation breakdown and arcing. Connectors made from dissimilar metals can corrode, creating a high resistance connection. This can also lead to overheating and arcing. Always use connectors that are rated for the amperage of the circuit and that are compatible with the conductors being joined. Make sure that all connections are tight and properly insulated. Electrical systems should be inspected regularly to identify and correct any potential hazards. Look for loose connections, damaged wiring, and corroded components. Pay particular attention to the grounding system and the neutral connections. Any problems should be corrected immediately by a qualified electrician. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before working on any electrical system. Ignoring or neglecting these safety measures can have dire consequences, potentially leading to severe injuries, property damage, and even loss of life. Prioritizing electrical safety is not merely a recommendation, it is an absolute necessity to ensure the well-being of individuals and the protection of property. Regularly scheduled inspections performed by qualified electricians are indispensable for identifying potential hazards and ensuring that the electrical system is operating safely and efficiently. These inspections should encompass a comprehensive assessment of all electrical components, including wiring, outlets, switches, circuit breakers, and grounding systems. Any signs of wear, damage, or deterioration should be promptly addressed and rectified. Furthermore, it is imperative to adhere to all applicable electrical codes and regulations, as these codes are designed to safeguard individuals and property from electrical hazards. Familiarizing oneself with these codes and ensuring strict compliance can significantly reduce the risk of electrical accidents. By diligently implementing these safety measures, individuals can create a safer environment for themselves, their families, and their communities. Electrical safety is a shared responsibility, and it is incumbent upon everyone to take proactive steps to mitigate the risks associated with electricity. Remember, electricity is a powerful force that demands respect and caution. By adhering to safety guidelines, staying informed, and seeking professional assistance when needed, individuals can harness the benefits of electricity while minimizing the potential for harm. A lost neutral in a 120/240 volt system creates a series circuit between the two 120 volt legs. Loads with higher resistance will experience higher voltage, while loads with lower resistance will experience lower voltage. This can cause some devices to overheat and fail, while others may not function properly. If the grounding clamp is loose, the system is not properly grounded, which can create a shock hazard. If a person comes into contact with a live wire and ground, they may receive a severe or fatal electric shock. To prevent this type of situation from occurring, it is important to ensure that the neutral connection is secure and that the grounding system is properly installed and maintained. All electrical work should be performed by a qualified electrician. The sequence of events typically unfolds as follows. Firstly, the neutral conductor at the service point becomes disconnected due to a faulty connection or substandard connector. Secondly, the voltage on the hot conductors doubles to 240 volts. Thirdly, as the temporary wiring lacks grounding, there is no designated path for the excess voltage to safely dissipate. Fourthly, the voltage accumulates within the wiring, posing a heightened fire risk due to potential overheating and insulation breakdown. To prevent such hazardous situations, several critical steps must be taken, one of which is to properly ground the electrical system in accordance with electrical codes and standards. This establishes a safe path for fault currents to flow, minimizing the risk of electrical shock and fire. Another step is to use properly sized and rated connectors that are compatible with the conductors being joined. This ensures a secure and reliable electrical connection, preventing overheating and potential failures. Additionally, implement a regular inspection schedule for the electrical system. This allows for early detection of any issues, such as loose connections, damaged wiring, or corroded components. Addressing these problems promptly can prevent them from escalating into more significant hazards. The grounding system plays a critical role in electrical safety, and any compromise to its integrity can have serious consequences. Regular inspections, proper grounding techniques, and the use of quality components are essential for maintaining a safe electrical system. Always consult with a qualified electrician for any electrical work or concerns.